All right, we're going to be switching gears today. Instead of looking at the angles in a circle, we are looking at the segments in a circle. We want to be really careful when you approach a problem because if you look at the first diagram, this looks identical to a diagram that we had yesterday, and it is. This is when we had the vertex of the angle inside the circle, and it was arc 1 plus arc 2 divided by 2. But when I look at the given information, I don't have angle measures and I don't have arc measures. What I have are segments. So just be really careful and pay attention to look at if you're dealing with angles or you're dealing with segments. So our first one, when I look at this setup, I have different segments and these are chords. Remember, the chords are segments in the circle that do not go through the center. So this is the chord-chord product because I have two chords in my circle. And to solve this, we see that the chords are intersecting and it's breaking each chord into two pieces. So this could be piece 1, piece 2. This is broken into piece 1, piece 2. So to solve this, we do piece 1 times piece 2 equals piece 1 times piece 2. And it doesn't matter which chord we look at first. So if I just look at the orange chord first, piece 1 is 5 times piece 2, which is x. And I set that equal to the product of the other one. So piece 1 is 10, piece 2 is 4. So then we get 5x is equal to 40. We divide by 5 and we find that x is going to be equal to 8. So the chord-chord product, we multiply the pieces of the chord together and set them equal to each other. Our second setup here is the secant-secant product theorem. So we have two segments. The first one is a secant. Again, we know a secant is a line that's going to intersect our circle in two spots. And then we have another secant, again, because it's intersecting at two spots. And for our secant-secant, this is the outside section, and then we have the whole piece. So to solve this one, it's outside times whole is equal to the outside times the whole. So if I look at the purple segment, the outside piece is 2. Now we've got to look at the whole segment. The whole segment is this entire length. And that segment was broken into two pieces. We add those pieces together. So it's 2 times x plus 2. The outside piece is 2. The whole piece is x plus 2. Over here, on the orange segment, the outside is 3. The entire length is 5 plus 3, which is going to give us 8. So then we distribute to solve. So we've got 2x plus 4. 3 times 8 is 24. We want to isolate that x, so we move the 4 over. 2x equals 20. It's 2 times x, so we divide to isolate. And we find that x is going to be equal to 10. All right, our last segment theorem is going to be the secant-tangent theorem. And if we look at our two different kinds of lines we have here, we have our secant, and the secant is the piece where you have the intersection twice, and then the tangent is where your line is only touching the circle in one spot. So the secant-tangent, again, you have a secant line and tangent line, the secant is going to be treated the same way. Whether you have a secant-secant or a secant-tangent, the secant portion is always going to be outside times whole. Now we have a new segment here, which is the tangent. And what we're going to do is we're going to square the tangent piece. So if I look at the secant portion, it's the outside, which is x, times the whole piece. Remember, the whole is the combination of those two, so we're going to add them. which is going to be x plus 5. The tangent segment is given to us there at 6, and we're going to square that tangent piece. We distribute our x, so we've got x squared plus 5x is equal to 36. We do see the x squared and the x, and yeah, we are going to factor. And remember, we can't factor until we have it set equal to 0. So we move that 36 over, giving us x squared plus 5x minus 36 equals 0. For our factoring, we're looking for the numbers that multiply to the outside and add to the middle. We are multiplying to a negative and adding to a positive. That means that when I break it down, I am going to have one positive, one negative. That's how I'm going to get my negative product. Because the sum, when I add the numbers together, is positive, the bigger number has to be positive, the smaller number is going to be negative. So we start with numbers that multiply to give us 36. We could think 3 and 12. Yes, and 3 and 12 multiply to 36, but they can't add to 5. If I do 3 and 12, I could get 15 if I added them. If I subtracted them, I could get 9, and I want 5. So let's look at other options. 9 and 4. If I multiply to get 36, add to 5, I would need a positive 9 and a negative 4. Then we set each piece equal to 0 and solve. So x is equal to a negative 9. X is equal to a positive 4. Again, we look at our diagram, and x is representing this segment right here, which means I can't be negative. I have one solution when x is going to be equal to a positive 4. So you've got 3 different situations here. Make sure that you're paying attention to whether it's angles or segments, because you have 2 different theorems depending on which piece you are working with. And that's it.